All right, welcome to this video, and we're going to take a look at a motion problem. This is from our constant velocity, and we're going to try to represent the motion in as many ways as possible. And specifically, we're going to do some practice on solving using mathematical models. So first of all, taking a look at this, let's read the question. It says car A is headed due east at 30 meters per second. Car B is initially 200 meters due east away from car A, and car B is headed due west, so in the opposite direction. So I don't know if you're like me, sometimes you forget which way is which. So east is this way, west is that way. So how about for this one, we're going to say that east is in a positive direction, and we'll make west in the negative direction. So maybe I'll put a plus in that direction and negative in that direction. When and where will the two cars pass each other? So how about, first of all, let's try making a motion map. Okay, so I've made a little motion map line. I'm going to say that this spot here is going to be my origin, 0. And since I've got this nice grid here, that's 5, 10, 15, I'll make this to be that 200 meters section away. And this is in the positive direction, and then this one would be in the negative direction. I'm going to do car A in blue. So car A, is headed due east at 30 meters per second. So we're going to assume it starts right here. So, and if it goes 30 meters per second, I can go 1, 2, put some dots in here like this, 1, 2, 3. I'll just do the rest of these dots. And then when I add the arrow, that goes halfway to the next dot. So each of those velocities is equal to 30 meters per second. So I'm just going to put in there 30 meters per second. Okay, so now the car B, which I'll put in green, starts at 200 meters per second, or 200 meters away, and comes back. You know what? Do I have room? Maybe I'll just put it just underneath here. So I'll put over here will be my green ones, and it's going at 25. So 5, 10, 25, 5, 10. So kind of like this, right? Okay, so I'll just do the rest. Okay, so it's not really clear how we're going to answer that question yet, because the question is when and where will the two cars meet? In other words, they're asking time equals question mark, and where along this place will they meet? Well, let's start thinking about our time a little bit. I think I need to make this smaller here. So this would be, for the blue, this would be time equals 0, right? This one would be time equals 1, time equals 2. In the meantime, for the green, this is time equals 0 because that's the start. I'll be able to put the green ones down here. This would be time equals 1, time equals 2. So after 2 seconds, they're quite far apart. After 3 seconds, that's where the blue is. Here's where the green is. Have not hit yet. At time equals 4, they have crossed. So the motion map is really helpful for visualizing what's going on, but it's really tough to get the answer. So really what we're saying is between 3 and 4 seconds. And where? What's the position when they meet? Well, let's see. This would be 50. So somewhere in, what would be a good guess here? Maybe somewhere around here would be my guess. Maybe between 100 and 110. That's kind of what we got here. Okay, so what's another way to solve this? Well, another way we could do this is by, very similarly, we could make a table. So here, I'll just make a nice little table. Okay, so I made my table with time, and we've got 2 different positions to keep track of. So it's really the same information. So if I put 0 here, 1, 2, 3, and 4, and we think, okay, so car A is moving east, and that's in the positive direction at 30 meters per second. They start at 0, and then they're moving up by 30. It's really the same thinking that we were doing here. We're just writing out the numbers. So here this starts at 20, or sorry, 200, and it's going down by 25s, 175, 150, 125, and now 100. So we kind of get the same information. It's going to be somewhere over there. And certainly, this is a pretty common approach here and to start plugging in numbers to pick a time. So if, your next one might be, hey, let me try 3.5 and to work that out, so that that you could still refine this table and fine tune it. But really we're still at between 3 and 4 seconds, and somewhere between 100 and 110 might be an accurate way of looking at it. Okay, so what about graphing would be another method. So we've got so far a motion map, we got a table of values, we could graph, and again we'd be using the same information. So let me just put together a little bit of a graph. Now I'm just going to do a sketch of my graph here. You could do it very accurately with graph paper or grid lines. I know this paper has grids on it, and try to get a bit more accurate. But I think what I'm going to do is I'm just going to sketch it here first. So the horizontal will be time here, so maybe I'll put time in seconds over here, and then this one will be the position in meters, and I know that we have to start up here at 200. Another one starts at 0 over here, and it seems to me that we're going to get to about 4 seconds, so maybe if I call this one 4 seconds, and just generally, okay, I'm going to get my really cool ruler over here, and I know that, well, how's this work again? The slope of this line is the velocity, and A is the one that is going a little faster, so I'm going to make that one a little bit steeper. Let's see how this works here, see if I can line that up. And then use my blue. Oh, no, I want my blue on that one, because that is car A. So that's how car A is going. And then car B is going a little slower. I'll try to make it even less steep, kind of something like that. Starts at 200, and it hits over there. Okay, and that's where it crosses. And again, I didn't get any better data right now, but I could do this. Okay, so our last one will be the mathematical modeling, and I need to sort of create some space here for me. I'll just get rid of that so I can create some more space. So my mathematical modeling or equations. Bring this over here. So our basic model of constant velocity, our model is that the position, x, is equal to the velocity times time plus its starting position, or x, its position at time 0. So what I can do is do for the two cars. So I've got car A. If I just go x equals vt plus x0. Now what are all the things that I know? Well, the velocity I was told I think was 30 meters per second, so I'm going to write 30 meters per second for the velocity, and the original position was 0, so I still have time here, and there's x. Okay, so at any given moment of time, if you plug in the time here, x will be the position of car A. So how about car B? So same idea, we're going to say that the x for car B is going to be equal to, now I don't think it was 30, I think it was minus 25. And then they started at 200. You'll notice that we've changed the y equals mx plus b here, and we've inserted the different things. Which actually reminds me, if you're doing it graphically and you wanted to get a really good answer, you could put it in Desmos, and I wouldn't mind spending just a minute to show you how to do that. So I'm just going to pop over there. Alright, so if you haven't used Desmos before, so Desmos, if I just type it in, the graphing calculator is what we want, and here we go. So we're not going to be typing in x equals vt plus x0. We're still going to put it into that y equals mx plus b form, so that the first car was in y equals mx plus b form, y is equal to 30x. And you see right away we get a graph there, and it looks pretty steep. So we can play around. We can play around with the axes and make it look a little bit better. So there's our first one. Our second one, moved around. Our second one was the car had a velocity in the other direction. So it was negative 25x, but it started at 200. So when I put those two in, now again I gotta kind of change the scale, make it all work. Oh, there we go. Gorgeous. Okay, so here we get our really nice looking graph. I haven't restricted the domain, so it's going into the negative and it keeps on going forever, but we could easily say where did they meet. If I put it on there, it'll tell me, hey, there's a great answer. I've got, oh, I made a mistake, didn't I? Instead of minus 35, it should be minus 25. I bet you some of you were thinking that. Okay, so I have an answer here actually. 3.636 is the x value, so that would be the position, and, oh no, that would be the time, pardon me, and 109.091 is the position. So we actually have a cool little answer there. So let's just pop back to where we're over here, and let's see if we can get a similar answer to that. At this point in our mathematical modeling, we have a car A in blue and car B in green. You might not be so lucky to have, so multiple. You might not be using the cool software I have. So you could differentiate this one by saying A, and that one would be B over here. So the position of car A at a certain time is 30 times t. The position of car B, oh, and I forgot one thing too. This is meters here as well. I forgot my units. Position of car B. So we're asking the question, when will they meet, right? I'll just write that out. When do they meet? How can I convert that into what that means in terms of x and t? What that really means is if xa equals xb, what's the time? That's really what we're asking. When do they meet, and where do they meet? So, but the key is that these two are simultaneous. In other words, the x and the t values are going to be the same. So it's really a system of equations. So what I'm going to do is just mathematically say, okay, 30t is going to be equal to, so I'm taking this part here and I'm saying it's equal to that part there. 30t is going to be equal to negative 25t plus 200. Now I'm going to add 25t to both sides. I'll get 55t equals 200. I'll divide both sides by 200. T is equal to 200 divided by 55. If I want to leave it as a fraction, I guess I could divide both sides by 4. So I could say, or by 5, I could get 40 over 11 seconds. If I wanted to type that in my calculator to get a sense of what that is, what is that value? I think it's 3.63 repeating seconds. Okay, so just a hint in this class, actually in all science and even math classes, if you're going to reuse this and you're using a calculator, put this in the memory. If you're not sure how to use the memory on your calculator, come and see me. I'd be more than happy to show you how to do that. So we've got one more part to do. We've got to say, well, where are they? What's the value for x? So just like you did in math class before, we can go to either equation here. I'm going to go back to this one. xa is going to be equal to 30 times the time. So it's going to be 30 times 40 over 11, or you could just have that 3.63 all repeating and just multiply by 30, and I think you're going to get, it works out to around 109 meters. And that confirms what we did graphically. Okay, so I hope that was helpful. I'm going to ask you to do a your turn here. So it's the same situation, but the car B is also going east. When and where will the two cars pass? And if you don't want to do the motion map and the graph, actually, if you don't want to do the motion map and the table, that's okay. But I'm going to say I want you to do it graphically and do the mathematical and using math. So try those both. Just to give you what I mean by car B is also going east is that, okay, if I draw a picture here, here's car A, and here's car B. So this one is going 30 meters per second, and this one is going 25 meters per second. So it's going to take a while, but A will meet up with B because it's going faster. Okay, so I'd like you to hit pause now, give it a shot, and then when you're all ready, come back and I'll show you my solution. Okay, so I didn't really do a graphical solution. I just sketched one here, and I showed I got to make sure that my car A is a steeper line than car B. Car B, my green one, starts at 200 over there, so and it has a less steep line as the blue one. So I identified here that here are my unknowns. I don't know what time they meet, and I don't know the position that they meet. Now when I look at the mathematical model, car A is 30 and car B, the only thing that's changed is now this is a positive 25 meters per second instead of negative. And you'll see how the math changes. This is the car A part. Here I'll do some highlighting. Oop, this is the car A part from over here. This entire section over here. Car B, this section over here is on the right hand side. So you see where this next line right here is where I say XA is equal to XB, and I just write the right hand side of the equations. The answer I get is 40 seconds and 1200 meters. And you'll notice I did good practice is I plugged them both in this. So this one here would be my check. All right. There is, oh yeah, I think I'll go on to the next video because that was a little bit long, where I will solve the super toughy question. So if you haven't already tried to do this super toughy Nelson Mack cross country runner, give it a shot first before you hear my solution. Okay, thanks.